This tire is 5 years old. I made it myself using liquid silicone. And today, we're going to find out if it was a complete waste of time. Because according to the internet, DIY RC tires are supposed to crack, dry out, lose grip, or completely fall apart. So I pulled out one of my oldest tires to see what actually happens after years of abuse. But first, let's talk about the foundation. Without this, your project is doomed before you even start.
Here's why picking the right silicone changes everything. All right, let's start with the basics. The most common question I get is, hey, why spend money on professional kits when I can just grab a $5 tube of silicone caulk from the hardware store and squeeze it into a mold? Look, if you do that, you're setting yourself up for a disaster. Here's the deal. Hardware store caulk is 1 part silicone. It needs air and moisture to cure. Plus, that sharp vinegar smell, that's acetic acid. It's nasty, and it can actually ruin your molds over time. I only use 2-part caustic silicones, part A and part B. When you mix these two, a chemical reaction happens that doesn't need air at all. It cures perfectly even, from the surface all the way to the core of the tire. It's predictable, it's stable, and it's the only way to get a professional result. Bottom line, caulk is for sealing your bathtub and window. 2-part silicone is for building high-performance parts. Don't mix them up.
Now, let's talk about viscosity. If you're not a chemistry geek, just think of it as thickness. Why does it matter? Because if your silicone is as thick as peanut butter, it's never going to reach the bottom of those tiny tread patterns. First, we have tin cure silicones. These are your workhorses, but they're usually thick, like heavy cream. They're great for simple molds, but they love to trap air bubbles. Then there's platinum cure silicone, my go-to choice. Usually it's much thinner, almost like milk. It flows into every microscopic detail of the mold. But be careful, platinum is picky. If your mold has any traces of sulfur or cheap 3D printing resin, it won't cure. It'll just stay liquid, forever. And finally, polyurethane. This stuff is thin like water when you mix it, but it has a very short pot life. You have to work fast or it'll turn into a solid block right in your mixing cup. In this lab, we're looking for that sweet spot, liquid enough to capture the detail, but tough enough to handle a brutal rock crawling session. Here's the deal. Every silicone has a shrinkage rate. Tin cure systems can shrink up to 2%, while platinum cure is usually much lower, around 0.5% or less. But honestly, don't let those numbers scare you. In the RC world, if a tire shrinks by a fraction of a percent, it's actually a good thing. It just means the tire will sit even tighter on the bead lock and stay secure during heavy loads. It's like a built-in tensioner. The most important advice I can give you, stop guessing and read the manual. Every bottle of caustic silicone comes with a technical data sheet. It'll tell you the exact shrinkage percentage right there. Don't worry about good versus bad silicone. There's no such thing, only the wrong material for the job. Read the instructions, know your numbers, and use that shrinkage to your advantage. Short answer? No. If you're worried about them rotting in your garage, don't be. It's a non-issue.
All right, let's get to the part you've been waiting for. This tire is 5 years old. Usually, by this time, cheap rubber starts to crack and fail. So the big question is, will it snap right now? Most high-quality casting silicones have an elongation at break of 200 to 500%. According to the technical data sheets, this means the material is designed to stretch 2 to 5 times its original length before it starts to tear. 5 years ago, I was using silicone with only a 200% rating. Think about this. This type of silicone is the same stuff used to make molds for heavy concrete castings. Those molds take a beating and can produce hundreds of copies without failing. If it's tough enough for industrial concrete, it's more than tough enough for your RC rig. I'll let you decide if that's durable enough for your needs.
Unless you're doing high-speed burnouts on hot asphalt every day, these treads stay sharp for a long, long time. But the real point isn't just about saving money. It's about legal cheating. By picking a specific shore hardness, you can tune your grip level to any surface, from rock-hard compounds for drifting to super soft, sticky formulas for extreme crawling.
The short answer is, it depends on what you're pouring. If you're using platinum pure silicone and the viscosity is under 6,000 units, you're usually good to go. It's thin enough for the air to escape on its own before it cures. Same goes for polyurethane. That stuff is so thin, bubbles aren't even an issue. However, if you're working with tin cure silicone or anything with a viscosity above 6,000 units, then yes, you definitely need a vacuum. Without it, those thick mixtures will trap air like a sponge, and your tire will end up looking like Swiss cheese. The secret is always in the manual. Check the viscosity rating before you buy. If it's low, save your money on the equipment. If it's high, you'll need the suction. I'll be 100% honest with you, I've never tried this, and I've never seen anyone else pull it off successfully. On paper, it sounds like a clever budget hack, but in reality, I have my doubts if it can create enough vacuum to actually work. I'm leaning towards impossible, but I want to hear from you. Have any of you tried the syringe trick? Is it a hidden gem or just a waste of time? Drop a comment below and let's settle this myth together.
The short answer is absolutely. Think of it this way. Vibration helps break the surface tension that keeps those tiny bubbles trapped against the walls of your mold. It coaxes them to the surface much faster than just letting the mold sit there. If you don't have a vacuum chamber, a vibrating table is your next best friend. Even a DIY setup like a sander without the sandpaper or just tapping the mold on the bench can make a huge difference. It's a simple step, but it's the secret to getting those crisp, perfect tread edges without the voids.
How do you make the tires hollow? And is it worth using rotational molding for this?
Not at all. It's much simpler than that. If you've watched my build process closely, the secret is in the central inserts. After I pour the silicone into the mold, I simply drop these cores into place. They displace the liquid material and form the hollow cavity perfectly as it cures. The beauty of this is the flexibility. If you want a traditional hollow tire to run with foams, you use the inserts. But if you want a heavy, solid core tire for maximum weight down low, you just leave them out. One mold, two completely different results. No rotate machines required. The truth is, you totally can. In fact, when you get my designs, I include both the mold files and a standalone tire file ready for 3D printing. I'm not here to stop you from experimenting. But there is a catch: detail. When you print a tire, you have to deal with supports. Wherever those supports touch the material, you're going to lose that crisp sidewall lettering and fine tread detail. It'll work, but it won't look factory. If you just want a functional tire and don't care about the scale look, print away. But if you want a tire that is indistinguishable from a high-end store-bought version with perfect details on every surface, casting in silicone is the only way to go. It's the difference between a printed part and a professional component. That's it for today's Q&A. I hope this cleared up the mysteries of DIY tire making. If you found this helpful, hit that like button and subscribe to the RC Tire Lab. It's the best way to support the research we're doing here. Don't forget to leave a comment with your thoughts or any tricks you've discovered. And hey, share this video with a friend. It is always better when you've got a partner to experiment with, compare results, and push the limits of what these RC rigs can do. Thanks for watching, and I'll see you in the next test. Now, go build something awesome.